Hi everyone, welcome to this demo on securing 5G network functions using Nimbus, an open-source runtime security enforcement engine built specifically for telco cloud-native workloads. I'm running this demo in a Nefio-deployed 5G environment, and I'll walk you through 4 real-world threats and how Nimbus helps mitigate them automatically and proactively.
The User Data Repository, UDR, holds some of the most sensitive data in the 5G core: long-term keys, subscription profiles, and other personal subscriber data. If compromised, this could lead to impersonation attacks or data breaches. The COCO workload intent likely aims to enhance security by ensuring that sensitive workloads are executed in environments that provide confidentiality and isolation. This could involve leveraging technologies like confidential VMs, which are designed to protect data in use, thereby reducing the risk of data exposure or leakage. Let's now look at the UDR pod. The runtime class of this pod is empty, indicating that it's a runC container. Let's verify this. Let's exec into the node that this pod is running on. Let's get the UDR container ID and the runtime details about the container. As we can see, it's a runt container. Now let's apply the COCO workload intent. This creates the COCO workload security intent and security intent binding. This in turn creates the COCO workload Kyverno policies required to mutate existing UDR pod to a use kata containers. Now let's inspect the pod again. We can see that it has the kata CLH runtime class. Let's verify this by checking the container details again. As we can see from the container details, the container has mutated to use kata. Next, we'll look securing network exposure functions. The network exposure function is the gateway between external applications and the 5G core network. If an attacker compromises the NEF pod, their next step is often to break out of the container sandbox, access the host node's file system, pivot to other workloads on the node, or modify NEF behavior. The escape to host Nimbus intent focuses on preventing potential vulnerabilities that could allow an attacker to escape from a containerized environment and gain unauthorized access to the host machine. The escape to host intent results in Kyverno policy and a couple of QBR policy. The Kyverno policy is applied at admission time, meaning it will validate pod creation requests before they are accepted by the Kubernetes API. The policy enforces a pod security standard at the baseline level, which includes basic security measures to mitigate risks associated with container escape. 3 QBR policies are also created to block specific Linux capabilities, block access to root binaries, which can be used to change the root file system of a process, and block access to various package management and build tools that could be exploited to manipulate the container or the host. Let's look at this pod, which contains host path volumes. This does not satisfy baseline policy constraints. Upon trying to create this pod, we can see the pod creation failing as the Kyverno policy is in effect. Let's look at the generated policy reports for the OAI core namespace. We can see that all the pods are compliant with the baseline pod security standards. In a 5G network, subscriber data is stored in core network functions like UDR, UDM, AUSF. Data exfiltration can happen when a malicious actor compromises a network function and extracts stored data, or there's insider misuse of privileged access. The DNS manipulation intent can be used to enforce policies that manage and restrict how pods interact with DNS services, particularly regarding outbound DNS queries. This can be crucial for security, compliance, and operational integrity. The DNS manipulation intent results in 2 policies: network policy and a QBARMR policy. The QBARMR policy is configured to block any unauthorized access or modifications to critical files, particularly /etc/resolve.conf, which is essential for DNS resolution in Linux-based systems. By securing /etc/resolve.conf, the policy effectively mitigates the risk of DNS spoofing or hijacking, which can lead to compromised network traffic and potential data leakage. The network policy created as a result of this intent includes specific egress rules to allow traffic to the Cube DNS service, thus ensuring that pods can resolve DNS queries through the designated DNS service within the cluster. Together with the network policy and the QBARMR policy, we create a layered defense strategy. The network policy restricts egress traffic to legitimate DNS services and IP addresses, and the kubearmor policy protects the integrity of the DNS configuration itself, ensuring that no unauthorized processes can alter it. Let's now go into the UDM pod and try to modify the /etc/resolve.conf file. As we can see, modifications to the file is blocked. We have also created a custom kubearmor policy, which is designed to enforce zero trust security on the UDM. This policy helps prevent unauthorized access to sensitive subscriber data and unauthorized network communications by tightly controlling what files the UDM container can access and what processes can run. Let's apply this policy. Now let's try to access the OpenAir UDM folder. This is again denied, as per our policy. An attacker who controls an external application function could potentially present a fraudulent OAuth access token to gain unauthorized access to network exposure function services. This highlights the importance of securing communication channels within your network. The Assess TLS security intent focuses on mitigating this risk by assessing the TLS configuration of your resources in all namespaces. This includes verifying aspects like TLS protocol version, certificate validity, cipher suite, compliance with FIPS 140-3 standards. Upon creating this intent, a cron job is created which runs the TLS scan every week. This is a sample report generated by the scan. The results show a widespread lack of TLS enforcement, with 12 services exposing insecure ports and 19 failing FIPS 140-3 compliance, which is critical for government and telco-grade security. For example, the OAI-UDR and NRF are exposing sensitive interfaces like HTTP and MySQL over plain text. That makes them vulnerable to data interception and token theft by a malicious network function. This highlights why enforcing proper TLS plus MTLS with verified certificates and strong ciphers is essential, especially in 5G where every NF interaction must be authenticated and encrypted.
Sign up for a personalized demo to see how AccuKnox can protect your 5G assets and help you stay ahead of emerging threats.